Hello and welcome to this discussion on fluid kinematics. Kinematics just describes the motion of the fluid and the different types of motion that a fluid can experience. Now, that means it's the study of how fluids are moving and deforming, how their shape is changing over time. And this can be complex. The fluid is moving, it's turning, it's bending. So it can be very complex, but we can usually divide the motion and deformation into several different groups or classes of motion. So we take the entire motion of the fluid particle and we break it up into essentially four different pieces. The first, most basic type of motion is translation. Translation is just moving a particle in space. It doesn't rotate, it doesn't change shape, it has its same orientation, it just moves from point A to point B. And this is what's described by the velocity field. Rotation occurs when a particle spins in place. It's actually described by the curl or del cross the velocity field. And it's important for turbulence and turbulent behavior of fluids. Fluids can also go through angular deformation. This changes the angles in the corners of a fluid particle. If it starts out as like a cubic shape, and then it becomes sort of a rectangular prism or some other shape. This is due to shear stresses, and it's usually symmetric. It's due to the effects of shear or viscosity on the flow. So you can see we have a rate of angular deformation that depends on the velocity gradient in the flow. We can also go through linear deformation. Here the angles stay the same, but the volume stretches or compresses in the various coordinate directions. It's also possible for the volume of the fluid particle to change. This is why we have this volume dilation rate, or del dot V, or the dot product of the gradient with velocity. This usually requires that the density of the fluid be able to change. So almost all fluid motions are some combination of these basic building blocks, and we're going to investigate fluid motions over the rest of this module.